Let's go over naming binary non-acidic molecular compounds. Now, just to remind you what molecular compounds are those compounds that do not have ions in them. In other words, there are no cations and there are no anions either. How do you distinguish molecular compounds from ionic compounds? You search for or you try to identify ions in the compound, and if you are not able to locate both cations and anions, then the compound would be molecular. If you are able to find one ion, there will be another. If there is cation, there will be anion, but if there isn't a cation, there cannot be an anion. So those are molecular compounds. We of course have not talked about acids, or so really I can't talk about non-acids. So we'll soon get to acids, at least in terms of how to recognize them. But binary means made of two elements, and that's all that binary is talking about. So when we are looking at compounds, molecular compounds for naming purposes in this class, we will only look at those molecular compounds that contain two elements. Okay, so let's go over the steps for naming them. Once again, when you look at the chemical formula of such compounds, we name the first element using the name of the element itself without any change. And then we name the second element in the chemical formula pretending that it is a monoatomic anion. In other words, we use the stem of the nonmetallic element name and attach the suffix "ide." Just as before that you saw, oxygen becomes oxide, hydrogen becomes hydride, nitrogen becomes nitride, fluoride, chloride, bromide, iodide, so on and so forth. So in exactly the same way, the second element in the chemical formula is named as if it were a monoatomic anion. Please remember, this does not mean that it is a monoatomic anion. It's a molecular compound. There are no ions. We are just pretending that the second element is a monoatomic anion for the purpose of naming. But we do have to do something else for such compounds, which we have not done yet. We must give the number of atoms of each element in the molecule using prefixes such as mono, di, tri, tetra, etc. So it is this rule, by the way, this step is only used for non-acidic molecular compounds. You should not use these replicating prefixes for ionic compounds or acids. It is only for this category of compounds. Once you have done that, you also need to remember that if there was only one atom of the first listed element, we do not use the prefix mono. That's the only prefix that we do not use for the first listed element. Basically, let me give you an example. For example, CO. We do not, if you follow the rules, you would have to say monocarbon, meaning one carbon atom, and then mono oxygen. So that would be monoxide, because we're pretending that the second element is a monoatomic anion, so oxygen becomes oxide. But according to this rule, if there is one atom of the first element, we do not put the mono. We do use other prefixes for the first element, just not mono. Now, for the purpose of naming such compounds, it is important for you to memorize the first 10 prefixes. Please memorize these. Okay, so let's use these steps to name a few such compounds. Okay, let's try this out. SiBr4. Now, it's not an ionic compound, so let's name it. Following the rules for naming from before that we just saw, we give the name of the first element as a without any change, so that is silicon, and then we give the name of the second element as if it were a monoatomic anion, so that is bromide, but we must also give the number of atoms of each kind using the prefixes. Now what prefix would go with silicon? Mono. And silicon is the first element, so we do not write the mono, but we do write for this. There are 4 bromines in there, so tetrabromide. That's one word. So the name of the compound therefore is silicon tetrabromide. Let's look at the next one. Now in this case, the first element is nitrogen, and there are 2 atoms of nitrogen, so we must say dinitrogen, and there are 5 oxygen, so which prefix goes with 5? Pentoxide. Now when let me just finish this. When 2 vowels follow each other, for convenience purposes, we don't write the first vowel. So instead of saying pentaoxide, we just said pentoxide. Instead of saying monoxide, monooxide, we just said monoxide. So when you have, let's say, if you had 2 O's follow each other, or an O and A follow, that's incorrect. If you had an A and O follow each other, so on and so forth, we drop the first vowel. That's just for convenience purposes, not to say that you would be wrong if you did not. Okay, so go ahead and pause the recording and name the following compounds using the same steps. As before, it is important to go from the chemical formula to the name, but it is equally important to go in the other direction. In other words, if you were given the name of a compound, you should be able to write a chemical formula. Now, when you see a name such as this is a huge hint. The prefixes, the replicating prefixes, as I said before, are only used for non-acidic molecular compounds. So as soon as you see the prefixes, it's a hint that this is not ionic, this is not an acid, it's a simple molecular compound. And then you just follow what the name says. It says tetrasulfur, meaning there are 4 sulfurs, and tetranitride. In other words, 4 nitrogen atoms in one molecule, and you're done. Now, should we reduce this down to SN because to the lowest ratio? Should we do that? The answer is no. Do not do that. For molecular compounds, the subscripts in the chemical formula give us the actual number of atoms in one molecule. We had to do that for ionic compounds because in those cases the subscripts give us the lowest ratio of ions. But these are not ionic compounds, these are molecular compounds. So in this case we do not do that. Okay, so following the same steps, please go ahead and finish and write the names of the compounds below. If you finish those, hopefully your answers and my answers match. And if there are any questions, please bring those or email me or bring those to our discussion session.